Hello everyone. In this session, we will go through this Kubernetes tutorial on using persistent disks with WordPress and MySQL. I will post the link in the YouTube channel as well. So before we delve into the exercise, we will go through the theory behind the persistent disk. So the link is here. I will also post it in the YouTube channel. So before we jump into the persistent disk, let's talk about volumes. Now we know in Kubernetes we have the node, and then the pod resides inside the node, runs inside the node, and then you have containers that are running inside the pod. Now one of the thing is the disks, the files that are inside the container are ephemeral. So we have a couple of problems here. So if the container crashes, the kubelet will restart the container, but it will restart it in a pristine mode. So any files that are stored in the container will be lost. The other problem that we also face is, say if we have two containers within a pod, so it is very hard for container 2 to share files which resides in container 1. Now the Kubernetes volume abstraction solves these two problems. So what is a volume? Basically, a volume is just a directory. So how do we use a volume? So when you create your manifest file for the pod template, there are two sections that you need to provide. One is what kind of volume to provide for the pod, what kind of volume that the pod wants to use. And that is right here. So in this case, we say we want to use an empty dir, empty directory. And then we also need to specify where to mount these into the container. So here we say that we want to mount this volume in /cache. So in your pod template YAML file, these two sections need to be present. What kind of volume and where to mount this. Now there are different types of volumes. So we'll start with the very basic one, the empty dir, empty directory. So as the name suggests, the volume is initially empty. There are no files in it inside the directory. And this is how you would specify this pod template. So here is the type of volume, which is the empty dir, and you want to mount it in /cache. Now here is your node, and here is your pod. Now the empty directory can reside in the node either as in memory, like in RAM, or as a persistent disk as in SSD. So the advantage is containers in the pod can all read and write the same files. So if you had two containers running inside the pod, now these two containers can share the same volume. So if the volume is in RAM, these two containers can share the same files. Now there is a disadvantage with this route. One is if the pod is removed from the node, for some reason the pod crashes, and then the Kubernetes controller decides to run this pod in a different node altogether, then the data is lost. Now let's look at another host path, which is another type of volume type, which is very similar to empty dir, except here the directory is not empty. So this one mounts a file or directory from the host node's file system. So here, again, there are these two sections that you need to provide. What kind of volume? So here we say some directory, and this resides in the node, and we want to mount it in test-pd. So here is your diagram. You have your node, your pod, and there is some directory inside the node, and this can have files, existing files already. Now containers in the pod can all read and write the same files, but we again run into the same problem where if the pod is removed for some reason from the node, the data is lost. Now, there are other types of volumes as well, but we'll just touch upon cloud volumes like generic cloud volumes. So here I'm talking about AWS, Elastic, Block Store, Azure Disk, Azure File, any volume that is provided by a cloud provider. So here in this case, so if you notice again, we have to specify these two, what type of volume type. So here we say AWS Elastic Block Store, we have the volume ID, FS type, and so on. And here is you have your node, your pod, and then the pod can access this volume in the cloud. Volumes can be pre-populated. Now the advantage here is if the pod is removed from the node, the volume is merely unmounted, so the files are not lost. Now there are some restrictions. So cloud providers, so they have some restrictions where the nodes must be running on the cloud provider instances. So if you're using AWS, then the nodes and everything has to be in AWS. Now, the other disadvantage in this approach, a little bit of a disadvantage, is if you notice this, what type of volume, uh, the user needs to know the volume ID, the file type, and so on. So this probably is not feasible for all use cases. You want to abstract this so that the user doesn't have to know all this information. Uh, so therein comes the persistence volume claim. And so in the persistent volume claim, we are trying to abstract these information, the ones that we saw in the previous slide, away from the ordinary developer. So this is what we saw in the previous slide. And again, like this information is too technical and the developer should not concern himself with this level of technical detail. So in order to abstract this, so what you can do is instead of providing all these technical details, you just provide what is called the persistent volume claim. You just give a name for the persistent volume claim, and in the volume claim, you provide what kind of storage you want. And all these technical details, you leave it up to either the administrator or the cluster or the Kubernetes cluster itself to figure it out. So with the persistence volume claim, all you would do is give a name of the claim, and then in your claim file, you would tell what you want. So here is your persistent volume claim. This is how your persistence volume claim, and this can be easily created by the user or by the developer. And all you say is, hey, I need the storage of 2 GB. So the user himself is not concerned with the technical details. So how does this abstraction work? So the way the abstraction works is there is another file called persistent volume. Now this is created by the administrator. Now the administrator, he knows all the technical details and so on, and he provides all the information for it to talk to the underlying cloud storage. Now, this kind of binding is called static provisioning. So here is your persistent volume claim. This is the persistent volume that is created by the administrator, and the binding that the provisioning that takes place is static. Now, the example, the tutorial that we are talking about, the Kubernetes persistence tutorial, uh, it does not use the static provisioning, so it uses what is called dynamic provisioning, and we'll talk about it soon. So, like I said before, this persistent volume file is created by the administrator. He knows all the underlying technical details, so he creates this file. And this persistent volume acts as an abstraction into the underlying physical storage that your cloud provider is offering. Now, say your persistent volume, your administrator has created these persistent volume. He has created one for 5 GB. He has also created another persistent volume for 10 GB. He has created another persistent volume for 20 GB, and he has created another one for 50 GB. So you as a user, as a developer, you come up with a claim. You create a claim and you only want 25 GB. Now, the binding takes place so that you at least get a minimum of 25. So all these, the 5 GB, 10 GB, 20 GB, they do not match your requirements. So the provisioning takes place with Persistence Volume 4, which has a size of 50 GB. So it meets your minimum requirement of 25 GB. Now, again, as I said, this is static provisioning, and this assumes that the administrator has created all these volumes for you. Now, there is a good chance that the administrator has not created any provisioning persistent volumes for you. So in that case, so the PVC, let's assume that the PVC has a matching persistent volume. So the administrator has created a persistent volume and it matches your claim, then static provisioning is used. But there is a good chance that the administrator has not created any persistent volumes. So you have a claim, but the administrator has not created any persistent volumes. In that case, dynamic provisioning is done. So here, the Kubernetes cluster itself will try to take care of your need by doing a dynamic provisioning, and it will allocate resources that match your PVC. So here, the administrator has not created any persistent volumes, but a dynamic provisioning happens. Now, even within dynamic provisioning, there are two ways of doing it. One is with dynamic provisioning. If the storage class is not specified in the PVC, we'll look at it, then the cluster default storage class is used. So there is a default storage class in the Kubernetes cluster, and that is used. And if the storage class is specified in the PVC, then that specified storage class is used. Now, in this example, in this tutorial that we are doing, we are going to use this most straightforward dynamic way. So here is your pod template, and here you have a name of your PVC, and here is your PVC where it says I want 200 gigabytes. Now there is no persistent volume that is configured by the administrator, so a dynamic provisioning happens, and since we have not specified any storage class, the default storage class is used. So this is the most straightforward dynamic way of doing it, and this is what happens in our exercise as well. So here, so since we're using the Google Kubernetes engine, so there is a default storage class installed in the Google Kubernetes engine. So here all we say is, hey, I want 200 gigabytes, and the default storage class is used. Now you can also have where, and now this is not part of the exercise, but if you had a storage class name specified, then you would need to have a storage class YAML file as well, and the administrator must create and configure the storage class. But this is not what we are doing, and we are also not doing the static provisioning as well. We're doing the dynamic provisioning, but where we use the default storage class. Now, the advantage with persistent volume is, so here you have the node, you have the pod, and it uses the PVC here, and this matches some PVC that you have, and which links to the storage in some cloud provider. Now, assume that this pod goes away. So this pod is no longer there, but the volume is still there, the PVC, the storage, the files are still not lost. Now, when the pod comes back again, it doesn't matter where it comes back up, it comes back again, this link to the PVC is established because it uses the same YAML file, and now it can access the files in this storage. Now, the other advantages also is you could have pods in multiple nodes using the same persistent volume, and they can also share files as well. That's it. In the next session, we will actually go through the exercise itself, and we will go through creating the persistent disk with WordPress and MySQL. Okay, if you like this video, please subscribe to the channel. Thank you. Bye.